Okay, the Lagrangian would be, so it will be plus lambda by u understroke minus this, right? U understroke minus this. Okay. Now we are having an inequality constraint. Right? We are having an inequality constraint. The constraint is not an equality constraint. Right? So when the constraint is not an equality constraint, right? Okay, what we really have is, if g of x is the constraint and lambda is the Lagrange multiplier, we have the result that lambda into the constraint must be equal to 0. Right, lambda into the constraint must be equal to 0. Have you done this? Sure, I'm sure you have done the Kantakar and all those things. But what does that mean? Intuitively, what does that mean? Why do you have to impose this condition? If you have an inequality constraint, what does it mean? Why do you have this condition of lambda or the constraint being equal to 0?
It shows optimum level of.
No. What you have is, think of a standard problem. This is your budget line. Okay? So this is x and this is y and this is the budget line. Okay? Or more traditionally, this will be y and this will be x and this will be the budget. What is the constraint? You have pxx plus pyy less than or equal to n. This is an inequality constraint. Right? Okay? What are we saying? We are saying that your optimal solution, when I say is equal, I am saying that my optimal solution must lie on this line. When I say less than equal, I am saying that my optimal solution can lie anywhere in this feasible region. So any set of conjunction bundles affordable to you. If it lies here, then what do I say? So my constraint is m minus pxx minus pyy is less than or equal to 0. Right? Is greater than or equal to 0. Right? M minus pxx py is greater than or equal to 0. Right? Now, if this condition is satisfied in equilibrium, that is my equilibrium is here, I want my indifference curve here, right? Okay? Sure? Right? Okay. But what does it mean? It means that if you now give me 1 more rupee, I'll be able to put myself on a higher indifference curve. Right? But what's lambda? Does everybody know the meaning of lambda? What is lambda? Marginality of money. That is, it tells me how much my objective function can increase, maximize value of the objective function can increase if I relax the constraint by a small amount. Right? Okay. Now, if I am on the budget line, if you give me 1 more rupee, I'll actually have more utility. Which means that lambda must be greater than 0. But if I'm on the budget line, then I must have this exactly equal to 0. Because m would be equal to pxx plus pyy. So if m is equal to pxx plus pyy in equilibrium, then lambda must be strictly greater than 0. Because I am maximizing on this. If you give me 1 more rupee, right, if you increase my income by a little bit, I'll actually be able to put myself on a higher indifference curve. I'll have more utility. Right? Sure? So therefore, if this is equal to 0, if lambda is greater than 0, this must be equal to 0. On the other hand, if this is not equal to 0, suppose I am here, right? So I am not spending all the money that I have. If I give you 1 more rupee, will my utility improve? No. I will not go on to buy, in the optimal solution, I will not go on to a higher indifference curve. Which means that lambda must be equal to 0. The marginality of money must be equal to 0. So if m minus pxx minus pyy is positive, lambda must be equal to 0. On the other hand, if lambda is positive, then m minus px minus py must be equal to 0. So in any case, the product of lambda and the constraint must be equal to 0. Right? Sure? Which is a very, very important idea and going to be useful in what I'm going to do. Okay? Right. So now, so what I'm going to do now is, so I just not write this whole part. Okay. So what I have is now, so this is my Lagrangian, right? This is my whole Lagrangian. This is my whole Lagrangian. Does everyone understand how to form a Lagrangian? You should understand the meaning of a Lagrangian multiplier. Right? Everybody knows what's a Lagrangian multiplier? How many of you don't know this? So let's quickly go over that. I think that's important to know, right? Okay, because you know why we write our utility functions like this? Why do we write a Lagrangian like this? The reason we write a Lagrangian like this is, so again go back to your two-person problem, right? I'll write this all again. Go back to your two-person problem. So you have this, you have y, you have x, you have the budget line, you have intervals. Right? So what do you have here? Equilibrium requires MUX by MUY to the slope of PX by PY. This is equilibrium condition, budget line and all that, right? From which you have yeah? But what does this tell you? What is MUY upon PY? So if Y is apples and apples cost 50 rupees or say 10 rupees a kilo, how much does 1 rupee of apples give you? 100 grams, right? Right? So if apples are 10 rupees a kilo or 100 rupees a kilo, what is, and if PY is the price of apples, what is 1 upon PY? If apples are 100 rupees a kilo, right? Okay, what is 1 upon PY? 1 upon 100. That is the amount of apples you can buy for 1 rupee. So 1 upon PY is the apples that you can buy for additional 1 rupee. What is MUY? The utility that you will get from those number of apples. So MUY upon PY is actually the additional utility you can get from spending your 1 rupee on apples. MUX by PX is the additional utility that you can get by spending your 1 rupee on oranges. And this says in equilibrium both must be equal. Right? In equilibrium both must be equal, because otherwise if you are better off spending 1 rupee on apples compared to oranges, then you are not in equilibrium. Then you will obviously consume more apples and less oranges. So if you are indifferent between spending money on apples and oranges, as you will be in an equilibrium, then the two ratios must be the same. Right? Okay. Now this ratio's correctively we'll call lambda. Right? This ratio we'll call lambda. So lambda tells you how much an additional rupee, how much additional utility a rupee can give you. Right? Now look at it this way. So from which it is very easy to see that MUX minus lambda px is equal to 0. Right? So you have MU minus lambda py must be equal to 0. But now if you write your Lagrangian as minus pyy, if you differentiate L with respect to x, right? So you have dabba L by dabba x is du set equal to 0. What is this? This is nothing but the marginal utility of x. So it is this equation. If you differentiate with respect to y, you are getting this equation. and you finally difference with respect to lambda, you get three equations in three unknowns. You can actually solve for MUX, MUY, lambda x. So this is nothing but the same condition, and that is why lambda really is this. It tells you how much you can get, additional utility you can get if I give you 1 more rupee. If you relax with that, it's called the shadow value of propensity. Right? Okay. Now, so clear? Sure. Now writing my problem like this, okay, the derivative like this. Okay, so the problem that I now have, I write it again. What I want to do is, I want to maximize I can write it as, actually I can just write it like this, plus okay. Let me think of differentiating L. Let me call this L. Okay. Right. Sure. Okay. What will that be now? So let me think of, in equilibrium, so think of E0 as the equilibrium level of output, equilibrium level of effort, because if I differentiate this, right, this will be U of this U and this, right, E of, right, first you need to differentiate this. So what I'll get is of E0 or if I want, I can actually write this like this. This will be a better way of writing it. Yeah? Because the constraint has to be positive or 0, right? Okay, so I write it like this. Because greater than 0, right? So this has to be greater than this, right? Or 0. So plus lambda, right? I write it like this. If I take the derivative with respect to Wx as the first quantity, what do I get? I use the chain rule. So minus will come out, minus Wxi, right? And W double dash xi, right? W double dash. So basically, derivative of b dash with respect to xi will be the first part. Plus say let lambda 0 be the equilibrium value of lambda, lambda 0, Pi of E naught and U dash everybody gets this? Quite simple, no? Chain rule here. So minus Pi of some effort level E0, we'll assume that the effort level is already determined, E0, right? Suppose, so we are only currently looking at maximum with respect to the wages. The effort level already is pre-specified at E0, right? So Pi of E0, V of, so minus comes out here, right? Minus comes out here, and then you have the, the derivative with respect to W. Plus, so you get this. Now, from this you get something very interesting. Okay, from this, what you get is, I write lambda 0 from this what I get is okay, right? Setting that equal to 0, I simply get this. Okay. Now this is a very insightful kind. This tells me two things. The first thing it tells me is b dash is greater than 0, u dash is greater than 0. So this ratio must be all greater than 0. So lambda 0 must be positive. Right? So if lambda 0 is positive, what does it apply for the what does it mean for the constraint? The constraint must be holding with an equality. So in equilibrium, the agent will be just as best, agent will be on his indifferent, on his reservation utility curve. So the agent, when it takes the contract, will have just the level of utility that he or she would have had, okay, by doing something else, which gives us reservation utility. So by taking the contract, the agent gets his or her reservation utility, the first. The second important thing that it says is, okay, so if lambda is greater than 0, right, okay, this also must be a constant, right? Is this working?
Yeah.
If this is a constant, right? Now, if this is a constant, you actually have something fascinating, right? If this is a constant, okay, think of a situation where the agent is risk neutral, right? So this is the agent's utility function. Sorry, this is the principal's utility function, this is the agent's utility function. Suppose the principal is risk neutral and the agent is risk averse. Okay? The principal is risk neutral and the agent is risk averse. If the principal is risk neutral, what will be the shape of his utility function? For a risk neutral person, what is the shape of the utility function? A straight line. So if you have a straight line, what is the slope of a straight line? A constant. Right? So B dash will be constant. B dash will be constant. But U dash will not be constant. Because the agent is risk averse. So the agent utility will be curved like this. The slope will be changing. Right? But if this whole fraction has to be constant, if B dash is constant, U dash will also have to be constant. Right? So the agent's marginal utility will have to be fixed. But the agent's marginal utility changes with the wage, which means that the agent must get a fixed wage. You see the point? Right? Which means that whatever the contingency xi, the agent ends up getting a fixed wage if the principal is risk neutral and the agent is risk averse. Because this fraction has to be constant. If this is constant, this has to be constant. So the agent ends up getting a fixed wage. Suppose it's the other way around. Suppose the principal who is risk averse and the agent is risk neutral. So if this is constant, for this to be constant, the principal will have to get a fixed amount. So what the agent will say is, I take ballpoint pens from you and give you a fixed amount every day, irrespective of whatever I sell. So the agent will work as a franchisee. Right? The agent will work as a franchisee. Right? Okay, whereas otherwise the principal will be insured by the agent. On the other hand, if both are risk averse, so that neither this nor this is constant. Okay? Fine, then we get something quite interesting. So if both of them are not this, see what do we get. Okay, what I get is, I go back to the original equation where I have, so if one is risk neutral and the other is risk averse, you know that the risk neutral person insures the risk averse person and takes all the risk, right? Because that is actually Pareto efficient, right? Because if you have a lottery which gives you, if you have a business which earns you about only 1,000 rupees per month, on an average, sometimes the business makes a lot of profit, sometimes it makes a lot of losses, right? And you don't like that risk very much, whereas I don't care about the risk, right? For me it's the same thing. Then of course I'll buy up the business from you, right? Okay, if you value that business at say 800 rupees per month rather than the 1000 which it on average gives you, then you will be happy to settle for say 810 rupees from me as a fixed payment, and I value that 1000 rupees risky at 1000 rupees certain, so I will actually value my 81 rupees less than the 810 rupees less than the 1000 rupees, so I will also be willing to get into a trade, so both of us will become better off from trading, and there will be gains from trade and the movement will be Pareto efficient, right? That's how the logic works, right? Okay, so now, but what if both are risk average, right? Then we have right, how can I write this? It is just that ratio which I have just turned it around. Now let me take the second derivative. Again let me differentiate with respect to xi. Right? If I differentiate this with respect to xi, what do I get? I get minus b double dash I get the double derivatives again. This is with to xi, this inside term becomes minus w double minus, so basically b double dash xi ka represent to xi, w0 ka dxi, right? This is what I get, plus lambda u, right? From which it follows, now I also know that lambda, okay, I also know that lambda is equal to right? So I can now put this lambda here, and see what I get. I get right, I can just substitute that value of lambda here, and so that will be b dash, so I can take b dash by b, u dash by u, right, and I can write it like that, right? Now do you recognize this? The measure of risk aversion for the principal, right? And this is the minus of the risk aversion for the agent, right? So I can rewrite this and then finally get the following. What I get is an important equation which says where RP is the measure of risk aversion of the principal, RP and RA is the measure of risk aversion of the agent, and dW0 by dxi tells you how the wages change with respect to output. So it says the change in wages. So if the ballpoint, if my man sells more ballpoint pens, then it tells me how much his wages should change with his sales in equilibrium, right? And it says that the ratio must be equal to RP upon RP plus RA, right? Where I have to calculate so greater the risk aversion of the principal, right? Greater the risk aversion of the principal. So what did it say? See, greater the risk aversion of the agent, smaller is the change in wages with respect to sales. So the agent gets fixed wages. Relatively, his wages don't move so much with sales. Whereas the greater the risk aversion of the principal, the larger is the change in wages with respect to output. So wages become more variable with outcome if the principal is more risk averse. If the principal is more risk averse. Okay? Sure? Is this clear? Okay, so this is what we call the baseline model. This is when the effort of the agent is completely verifiable. But the agent effort can also be non-verifiable. Right? We are not sure about what they, in which case this will change a lot. Right? And which you will see in the next class. Sure, so thank you very much for sitting through this.